So we're going to be looking at another aspect or another application of derivatives and what we can do with them and what type of information we can gather from them. Namely, what we're going to look at is the graph of the function, and we're going to create the graph of the derivative here. And in order to create this properly, we need to understand what's going on with this. One thing I always say about calculus is it's actually the sociology of math, which means we're studying the behavior of curves, right? We're studying how do these curves behave, what information can we pull out of them, what are the different things that they have, what are their different attributes, all these different questions we can answer just by looking at this curve or the equation for this curve and looking and identifying the behavior of its derivatives at given points, meaning the tangent line slopes at different points. Okay? So as we look at this, let's just kind of pick some arbitrary points. I have a couple labeled here, and I purposely kind of put this so it's not really centered anywhere. It's not intentionally one-to-one or non-one-to-one. It's not intentionally anything here other than just kind of arbitrary. And I didn't want us to, I wanted to make sure that this was set up in such a way that it's obvious that what we're dealing with here with A is any given value here is not because it's of its position or what this curve looks like. Okay, so we're talking a lot of generalities when we go through this problem. So let's start with this, and let's start with the left-hand side of this and work our way across to the right. As we look at the left-hand side of this curve, we notice that it has negative position and a positive position, right, in terms of the y values. But the other thing we also notice is right here on the left, the slope over here for just about any tangent line I draw right there is positive, right? Now that happens all the way up until we get to this arbitrary point of B, where all of a sudden the slope becomes 0, right? And then we have this slope that is negative here. And then again, right here at this arbitrary point of A, we have the slope of 0 again, because it goes horizontal again. And then over here on the far end, or on the far right of this, we have a slope of positive again. This correlates with the function being increasing, neither increasing or decreasing. We'll come back to that. Decreasing, neither increasing. All right? So, let's translate that information over to here. Keeping in mind that we have x and f prime, which means that what we're talking about here are the slopes, right? So over here, all the way up until the time we get to B, the slopes are negative. So we're talking about negative slopes, right? And so maybe we're looking at that saying, well, that's a positive slope. We're not looking at its direction, we're looking at its position. So the position over here with this one corresponds to the slopes. Maybe I should put S's, right? The positions over here correspond to the slopes over here. So we're going to take these slopes from over here and we're going to translate them into positions on this side. So over here, well, do we have that done correctly? Because it's in the same positions, isn't it? But that's not what we want, right? So what we really want to do is we want positions, then we want it to be positive to that spot, right? Draw that as best I can. Now we're talking about positions to slopes, right? And then what happens right there at that arbitrary point B? The slope is 0. So the position has to be 0. And then what's happening between B and A? Well, it's a negative slope, so it has to be down here like that, right? And then over here we have positive slopes, so these positions over here have to be positive again, with A again being a 0 slope, which occurs right there. Now, I want to smooth this out a little bit so it looks prettier. We can do that. Again, keep in mind that this is an arbitrary point. And if you remember this one kind of looks like a cubic function. This kind of looks like a quadratic, which makes sense when you think about the derivative. The derivative of a cubic would be a quadratic, and this would have the shape of a quadratic, which makes sense. So we're talking about positive slopes here, which are positive positions, right? Here we have negative slopes, which means we have negative positions on that curve. And over here again we have positive slopes, which means we have positive positions. Okay? So you have to remember that this curve over here is graphing slopes as positions. So the slopes from over there become the positions over here. Now let's talk a little bit more about this value A and B here. Okay? Over here we had a maximum where the curve went from an increasing to decreasing. Notice how I'm saying that. Notice what I'm pointing to. It's going from a positive slope to a negative slope. It's going from an increasing function to a decreasing function with the function. And notice I'm pointing to the values for the derivative here. So this point of B right here, that is a max because it goes from positive to negative. Over here with values A, we're going negatives, right? Negative slopes to positive slopes. We're going from a decreasing function to an increasing function. Over here, we're going from negative positions to positive positions. There's a zero in between, and that zero in between signifies a minimum value. Right? Now we can start talking about locals and absolutes, but that's a whole other aspect of what's going on with this. The big thing is that we're identifying that these positions over here with the function are kind of meaningless in terms of what's actually happening with the derivatives, right? So over here we have a positive position, okay? But here we have a negative position. So positive and negative position over here didn't affect this part of the derivative at all. It's all about the function is increasing, which means the slope is positive there. Over here we have positive position and negative position, but all of the position here is negative because all the slope is negative. And then in this last one, once again we have negative positions and positive positions, but going back to this we have only positive positions over here because these are positive slopes corresponding with the increasing function right there. Okay, so if we were talking about where's this function increasing? Right? This function is increasing from negative infinity to B, and then again from A to infinity. And it is decreasing from B to A, which corresponds with this curve. Okay, the curve of the derivative. All right, so this is what we call curve sketching, and this gives us a lot of useful information, and this is directly related to first and second derivative tests and how we can use those. Something else to notice here is that we actually have something called a point of inflection. Right about here, we'll call this, say, point C, and that corresponds right there to that position. Okay, the minimum here of this curve is that point of inflection right there with this curve over here. That point of inflection is where we change concavity, which means where it goes from opening down to opening up. Over here, notice the slopes with the derivative switch from negative to positive. Down, up, negative, positive. It's all related, all right? Cool. All right. So I hope this was useful. Hope you enjoyed calculus more than you ever have. And just remember, it's all about change, all right? So keep mathing on and reach out with questions and comments.